Hi, Matthew. So I'm making this video to help with lesson 4. So as we're going through this video, I'm going to kind of model for you how you should take some notes. We're not going to take a ton of notes, but you will want to have a piece of paper that you can write down a few important things on. And I'll kind of go back and forth between my paper and the lesson. So go ahead and get a piece of paper. If you need to pause the video, do that. And the other great thing about having a video is you can pause anytime or rewind and hear what I say again. So hopefully this video will be helpful. So this lesson is all about sequences, and sequences are just basically a big string of numbers. So let's go down here. So a sequence is a function whose domain is the natural numbers. Okay, and you can always click on these words too, and it'll tell you what they are, like the vocabulary. The Fibonacci sequence looks like this. Fibonacci sequence is just a really famous sequence that's used a lot in math. So here's an example. The pattern continues forever. Can you figure out what the pattern is? So each term in the sequence is determined by adding the two previous terms. So it's kind of like a little puzzle. You got to figure out what is the rule here? How are they coming up with the next number? So if you add 0 and 1, you get 1. If you add 1 and 1, you get 2. If you add 1 and 2, you get 3. So the rule here is adding the previous two terms will give you the next term. Okay, so it just says the Fibonacci sequence is one of the many types of sequences that you come across in mathematics in the real world. Okay, consider the following sequence. The first term is 5, and to find the next term, subtract 2, then multiply by 2. Then take the result and subtract Then take that result, subtract 2, and then multiply 2. Repeat with each term to generate a sequence. So they're giving you a new sequence. So here it is right here, 5, 6, 8, 12, 20. So what they did is they took the the term and subtracted 2. So like 5 minus 2 is 3, and then multiplied by 2. 3 times 2 is 6. And then they took that 6 and subtracted 2 and got 4 times 2 would be 8. And so that's just another example of a rule to create a sequence. Each term in a sequence is assigned a number. So for example, the first term was 5. So they could write it as an ordered pair. So here was that sequence again. This is just listed out as a bunch of numbers, but here it is written as an ordered pair. So like the first term was 5. The second term was 6. The third term was 8. So this right here means the same thing as this. It's just written in two different ways. Okay, here's a new one. If you're given the first few terms of a sequence, analyze the relationship between the terms to find the pattern. So let's look at this one. 2, 13, 24, 35. So to get from 2 to 13, you add 11. Let's see if that works all along. So 2 plus 11 is 13. 13 plus 11 is 24. 24 plus 11 is 35. So it looks like it's working here. So that's the rule for that sequence. So each sequence is going to be different. Everyone's going to have a different rule, and it's kind of your task to figure out what the rule is. Sequences can also be described with function notation. So you've seen this f of x notation before. So this is just another way to write a sequence. So like 6x minus 3. To create a sequence out of that, we would plug in numbers. So like I want to plug in 1 to figure out what the first term in the sequence is. So if I plug in 1 right here, 6 times 1 is 6, minus 3 would be 3. So that's how they got that the first term was 3. If I want to figure out the second term, I'd plug in 2 right here. 6 times 2 is 12, minus 3 would be 9. So you can use this function notation to figure out a sequence as well. So that's what I just said. You can plug in the different numbers. Okay, one thing I do want you to write down. Whenever you see one of these boxes, it's usually something important. So natural numbers are positive integers starting with 1. So I'm going to flip over to my notes here. Natural numbers. Positive integers. That means like no decimals or fractions. Starting with 1. So the natural numbers are like 1, 2, 3, 4, 5, and goes on and on and on. There's not 0. There's no negatives. Okay. So that's one thing I want you to write down. Let's look What else we have here? So as we go through the lesson, they're going to give you some examples to try. All right, so Natalia notices that the number of flowers on a bush each month follows the sequence 2, 5, 8, 11. This means in the first month there were 2 flowers, the second month there were 5 flowers, and so on. If the pattern continues, how many flowers should Natalia expect to see on the bush after 6 months? So we're looking for the 6th term in that sequence. Okay, so first find the pattern. How can you get from 2 to 3, or sorry, 2 to 5, and 5 to 8, and 8 to 11? So I kind of gave it away there with my saying 3. It looks like we're adding 3 every time to get from one term to the next. So let's see. Yep, you're adding 3 every time. So I like the way they do this and have you check your work. Okay, so now let's try to find the 6th term in the sequence. So this was the first term was 2. Let me go back up. So we have 2, 5, 8, 11. So that's the 4th term. We need to go 2 more terms. The 5th term, if I add 3, would be 14. And if I add 3 again, I would get 17. So the 6th term in the sequence should be 17. Let's see. Yay, 17. Okay, so now it says you're ready to complete some problems on your own. Okay, so I'm going to stop this video and let you go ahead and do those problems, and I'll make a video for the next part of the lesson too.